Hello, today we'll be demoing our app, HeroTyper. The idea behind the app is quite simple, to create a fun and interactive way for people to boost their typing skills and accuracy. As you can see, we took this idea and developed a space-themed arcade shooter. So without further ado, let's see what we developed. First, we have 3 levels, easy, medium, and hard. Each level affects difficulty of the words that you'll need to type, what kinds of enemies will show up, and how often they appear on the screen. As a player, the objective is simple. You position your turret below incoming asteroids, type the word to shoot a projectile at them, and try to collect as many points as you can before you run out of lives. The asteroids that come down each have a few different properties indicated by their design. If they collide with the base, or in other words, the bottom of the screen, you lose a life. Shooting them will give you points, and a chance at receiving bonus items. These bonus items, like extra lives and bombs, require you to pick them up by touching them with your turret. Bombs can be fired tactically to do 1 point of damage to all enemies on the screen, but as time goes on, the enemies will spawn faster, so the player needs to be careful in rationing resources. In developing this game, we really prioritized the user experience. We'll now cover some of the technical challenges involved in making this a reality.
When evaluating the biggest technical challenges that we faced when developing the game screen, it was mainly related to performance, and the other was extensibility. So for performance, we had to evaluate the effects on the gameplay when having a predominantly synchronous or predominantly asynchronous operation within the code. So for the asynchronous operation, we were thinking of implementing an event-based architecture that would have allowed us greater modularity within the code, but that would have inhibited the performance because the different elements would try to render themselves onto the main thread at different times, and those times may or may not be coordinated well enough for it to render everything at an optimal frame rate. So we opted out to choosing a synchronous behavior predominantly within the code, which allowed us to render in a more predictable fashion and thus be able to render elements at a more optimal frame rate. We also faced technical challenges with sound, as a sound player for Android is not available at all times, and that was causing our UI to block. So we had to poll the sound player at set intervals in order to avoid that issue. We also implemented a cache for commonly used bitmaps within the game in order to improve the performance. This was able to be done by removing a lot of the redundant logic that was being called and reduce the amount of unnecessary computations that we had to make in order to generate those bitmaps. Now, looking at the extensibility issue, that was also a challenge for us. This was due to the fact that the game specifications were evolving over time as we were building out the code, and this required our implementation to be modular and also extensible enough to accommodate that change. We avoided this issue by following the necessary design patterns as we see fit. For example, we implemented the strategy pattern to accommodate spawning enemies dynamically with intricate modifications amongst the different enemies that were being spawned.
The user can access the stats page and see improvements over time whenever they want. The statistics show how their typing speed improves, shown as a graph on the bottom, and how often each key is correctly typed or mistyped, shown by the colored keyboard at the top. This is a core user scenario, as we believe one of the main use cases for our users would be to improve speed and accuracy of typing. I will now talk about the technical challenges we faced with the statistic. Because we were aiming for extensibility and the ability to add more features in the future, we had to design the statistics differently than other game objects. Instead of having a stats object, we decided to create a stats model and presenter. This way we would stick to our main layered architecture design by having a simple database layer. Although this is not truly a database layer because we need to have a physical database somewhere, this design allows for a smooth extension of the database layer in the future. The shared preferences module for Android was the underlying technology for our database, but it only allows for limited data structures to be stored into persistent memory. We had to implement custom logic to serialize and deserialize fetched objects in order to fulfill our requirement.
Now let's talk about the settings activity. So in the settings activity, you can set the background volume and the sound volume. And more importantly, you can also set your own keyboard style, which users can choose from a few preset layouts, such as QWERTY, Dovrak, or Comac, or build their own custom layout. There were several technical challenges that we had or encountered when creating a customizable keyboard. Because the keyboard can be inflated with different sizes, depending on what activity it's being shown in, such as main game or stats page. So with the original structure of a keyboard, we would need to make at least 2 different sizes for each keyboard layout that we introduce. This approach has both pros and cons. Once we have all the keyboard layouts for all the sizes, we can immediately inflate whatever layout users choose. This would make the game more performant since the game doesn't have to waste resources to set the keyboard up before the game starts. However, since the eventual goal is to make the keyboard more customizable, we decided to dynamically set the keyboard up at runtime, implementing a strategy pattern. This would make the game load a little bit slower on the first time after the layout is chosen, but it would allow users to design their own personal keyboard, with extra keys in case users need multiple copies of the same characters on their custom keyboard. Storing the keyboard configuration is also another big problem that we had encountered. Initially, we were planning to store it in a model object since our main architecture is MVP. Once that object is stored, we can pass it around so that the main game and the stats page can have access to the keyboard configuration and load the correct layout. However, since the keyboard model has to be written in the settings activity and then pass it up to the main menu activity, and then it propagates down to stats activity, this would incur too much overhead and introduce extra unnecessary code complexity. So we decided to save it to share preferences, which is a native Android key value in-memory database that any activity in the package can access. This helps prevent unnecessary transfer of data to intermediate entities such as the main menu.
Thanks for listening, and expect to see HeroTyper on the Google Play Store in the upcoming few days.